You slept 8 hours. You're still exhausted by 2 p.m. And it's not in your head. It's in your cells. Every one of your trillion or so cells is packed with tiny power plants called mitochondria. When you feel tired with no obvious cause, the most common hidden culprit isn't your brain, your willpower, or your sleep schedule. It's that some of those power plants have quietly gone on strike. Every single thing your body does, thinking, moving, digesting, even healing a paper cut, runs on a molecule called ATP. And mitochondria make almost all of it. Here's the twist most people never learn in school. Mitochondria aren't originally yours. They used to be independent bacteria, separate living organisms, that got absorbed into our cells roughly 2 billion years ago and never left. You are, quite literally, walking around powered by domesticated bacteria. And when that ancient arrangement breaks down even slightly, you don't get sick in an obvious way. You just get tired. All the time. For no reason anyone can find. Around 2 billion years ago, a larger primitive cell swallowed a smaller bacterium, and instead of digesting it, kept it alive. That bacterium was extremely good at one thing: burning oxygen to generate huge amounts of energy. The host cell got a built-in power plant. The bacterium got permanent shelter. Neither one could go back to living alone after that. That's not speculation. It's why mitochondria, to this day, still carry their own separate loop of DNA, completely different from the DNA in your cell's nucleus. Every mitochondrion in your body is essentially still running its own genome, 2 billion years after moving in. It's the strangest, most successful roommate arrangement in the history of life on Earth. And your energy levels depend entirely on how well that arrangement is still working. Inside each mitochondrion, an assembly line called the electron transport chain does the actual work, passing electrons down a series of protein complexes to generate an electrical gradient which spins a molecular turbine and stitches together ATP. When mitochondria are damaged by chronic inflammation, poor sleep, certain viral infections, or just accumulated wear over the years, that assembly line doesn't stop cleanly. It sputters, output drops, and it leaks reactive byproducts that damage nearby cell structures, including the mitochondria's own DNA. Your cells do have a cleanup system for this, a process called mitophagy, where damaged mitochondria get tagged and recycled. But if damage happens faster than cleanup can keep up, or the cleanup system itself gets sluggish with age, the ratio of working power plants to broken power plants quietly tips in the wrong direction. You don't feel individual mitochondria failing. You feel the sum of it, fatigue that sleep doesn't fix. This isn't theoretical. Researchers studying older adults with unexplained chronic fatigue have taken muscle biopsies and found measurably lower mitochondrial content and weaker build more mitochondria signaling compared to non-fatigued people of the same age, even when nothing else about their health looked obviously different. The same pattern shows up in myalgic encephalomyelitis, also known as chronic fatigue syndrome, and in long COVID. Both are now under serious investigation as conditions where mitochondrial energy production gets disrupted, sometimes for years after the initial illness has cleared. Even in autoimmune conditions like Sjögren's disease, researchers have found measurable mitochondrial dysfunction in immune cells that correlates directly with how fatigued patients report feeling. Different diagnoses, same downstream failure, not enough working power plants to meet demand. Here's the part that makes this genuinely useful instead of just alarming. Mitochondria aren't fixed in number. Your cells can build more of them, a process called mitochondrial biogenesis. And the single strongest trigger for it, by a wide margin, is exercise. When a muscle cell is put under real physical stress, it activates a protein called PGC1-alpha. Think of it as the foreman that orders new power plants to be built. Endurance-type exercise in particular can meaningfully increase mitochondrial density in trained muscle over weeks to months. This is the genuinely counterintuitive part. If you're exhausted, the instinct is to rest more. Sometimes that's correct. Real recovery matters. But moderate, consistent movement is one of the few interventions actually shown to increase your cell's energy-generating capacity, not just temporarily mask fatigue with caffeine. Now, the necessary caveat. Being tired after a bad night's sleep or a genuinely exhausting week is not mitochondrial disease. Most fatigue is completely ordinary and fixed by, in fact, sleeping and resting. This video is not a diagnosis, and it's definitely not permission to buy the mitochondria boosting supplement stack being advertised to you right now. The evidence for most of those is thin at best. CoQ10 and a few other compounds have some legitimate research behind them in specific clinical contexts, but extreme unexplained fatigue that persists for months despite adequate sleep is a conversation to have with a doctor, not a supplement aisle. What the research does support without much controversy, exercise, consistent sleep, and reducing chronic inflammation are the levers that actually move mitochondrial function, not a pill. So the next time you're exhausted for no obvious reason, it's worth remembering, you're not lazy and you're probably not broken. You're running on 2 billion-year-old borrowed bacteria, and right now, some percentage of them just aren't pulling their weight. The fix isn't usually more willpower, it's giving your cells a reason to build more power plants. Next time in this series, I'm going somewhere even stranger. Your scars. Why the tissue that heals your skin isn't actually healed skin at all. It's a permanent evolutionary shortcut your body took instead. Subscribe if you want that one when it's up. And if you've made a real dent in chronic fatigue through exercise or sleep changes, I'd genuinely like to hear what worked. Drop it in the comments.